Hey guys, now that we've learned quite a bit about linear equations in one variable, it's time to put our knowledge to use by solving word problems when we use all of what we've learned about linear equations in one variable and apply it in real world scenarios to find answers to questions. Now, I don't want to give you a specific method that you need to memorize and then apply on repeat robotically, because mathematics is all about being artistic, creative, and innovative. I want you to think on your feet, but think absolutely logically, and I promise you, you will always be able to crack it.
Pause the video after hearing each question and give it a shot yourself before you listen to Bhavya's solution. Question 1.
The height h, in feet, of a plane t minutes after taking off, is given by h equals 3400 t plus 1000. Find how many minutes after takeoff the plane takes to reach a height of 18,000 feet.
So we need to find at what time, that is to say, for what value of t will the plane reach a height of 18,000 feet? That is to say, will the value of h be 18,000? Now, interestingly enough, this question has given us an equation itself, which is h equals to 3400t plus 1000. Now we need to find t, so the time is unknown, but we've been given a value of h, that is 18,000 feet. Therefore, I can restate this entire word problem as just being solve for t in the equation, not h equals to, but 18,000 equals to 3400t plus 1000. And now we have got all of the things as constant except one variable. So let's just keep transposing and isolate t. So we transpose 1000 from the RHS to the LHS. We get 18,000 minus 1000 equals to 3400t. Therefore 17,000 equals to 3400t. Transposing 3400 from the RHS numerator to the LHS denominator, we get 17,000 upon 3,400 equals to t. So 17,000 upon 3,400, we've got two zeros on the right of the numerator and two zeros on the right of the denominator, so we can cancel them. So we are left with 170 upon 34. The reason why I did this cancellation of zeros is because we essentially just cancelled out the common factor of 100, if you think about it. So we've left with 170 upon 34 equals to t. 170 upon 34, of course, is nothing but 5. Therefore 5 equals to t, or t equals to 5, and therefore we can say that our answer is after 5 minutes will the plane reach the required altitude of 18,000 feet.
Question 2.
A repair bill for your car is Rs 5,000. The parts cost Rs 2,600. The labor cost Rs 400 per hour. Find the number of hours of labor spent repairing the car.
This time around, we haven't gotten an equation in the question itself. So we need to construct or conceptualize an equation which represents the situation described in the question. So let's think about it. We've been given the cost of a repair bill, and then we've been told that there is, as part of that repair bill cost, the cost of parts and the cost of labor. So can we say this? Total cost of repair bill equals to cost of parts plus cost of labor? Yes. And then let's put in the values that we have been given in the question. So the total repair bill cost is 5,000 rupees, and the cost of parts is 2,600 rupees, and the cost of labor is 400 rupees per hour. if a person works for 1 hour, that is 400 for 1 hour, but then if a person works for 2 hours, then the cost would be 400 into 2. For 3 hours, you'd get 1200 rupees. But we don't know how many number of hours of labor was involved in fixing this car, do we? So let's use a variable there. Let the number of hours of labor involved be n. Therefore, we can now put in the values that we identified from the question in the equation that we ourselves formed and say that 5000 equals to 2600 plus 400n. And we need to find the number of hours of labor. So we just need to solve for n in this equation. So let's just keep on solving. Transposing 2600 from the RHS to the LHS, we have 5000 minus 2600 equals to 400n. Therefore, 2400 equals to 400n. Transposing 400 from the RHS numerator to the LHS denominator, we have 2400 upon 400 equals to n. And now there are 2 zeros to the right on both the numerator and the denominator numbers in the LHS. Therefore, we can cancel them, which is again the same as just cancelling out the common factor of 100. So we have 24 upon 4 remaining, which is of course nothing but 6. Therefore, we have 6 equals to n, or n equals to 6. Our final answer is that 6 hours of labor were involved in this car repair.
Question 3.
An amusement park offers a special pass for $90 that allows you to buy tickets for individual rides at half price. If you buy the pass, the cost in dollars of buying T tickets is 90 plus 22.5 T. Otherwise, the cost of T tickets in dollars is 45 T. Find the number of tickets you must buy for the two costs to be equal.
Now there are two possibilities here. The cost with this Super Saver discount special pass and the cost without it. So cost with pass equals to 90 plus 22.5t and cost without pass equals to 45t. Simply, this is information that is given in the question. And the question is asking us to find the number of tickets or the value of t for which cost with pass equals to cost without pass. So we will just equate the two expressions, cost with pass and cost without pass, and get the equation 90 plus 22.5t equals to 45t and solve for t in it. So let's go ahead and do that. Transposing 22.5t from the LHS to the RHS, we have 90 equals to 45t minus 22.5t. Now 45 minus 22.5 is actually nothing but 22.5 itself. So 90 equals to 22.5t is where we have reached. Transposing 22.5 from the RHS numerator to the LHS denominator, we have 90 upon 22.5 equals to t. But 90 upon 22.5, if you calculate, gives us the simple number 4. Therefore, 4 equals to t, or t equals to 4. Therefore, you need to buy 4 tickets in order for the cost with or without this Super Saver pass to be one and the same.
Question 4.
The sum of twice a number and half the number is 10. Find the number.
Let the missing number be k. So the variable can be represented by any alphabet, as you might remember, k, x, y, n, or as we did in previous questions, t, whatever alphabet you like or find convenient. Anyways, this question is talking about twice a number and half of that number. So those would be represented by 2k and k upon 2 respectively. Now the question is saying the sum of twice a number and half a number. So we are talking about 2k plus k upon 2. And the question is saying sum is 10. So equals to 10. So the equation that we have formed in order to find this number is 2k plus k upon 2 equals to 10. And now in order to find the missing number, all we need to do is solve for k in this equation. So 2k plus k upon 2. If you know your fractions, then 2k can be thought of as 2k upon 1. We need the denominators of both of those fractions to be the same. So the LCM of the denominators 1 and 2 is 2. So 2k becomes 2k upon 1 whole multiplied by 2 upon 2, that is to say 4k upon 2. So 4k upon 2 plus k upon 2 becomes 5k upon 2. So the equation is now 5k upon 2 equals to 10. Now we will just transpose 2 from the LHS denominator to the RHS numerator. Thus we have 5k equals to 10 into 2 equals to 20. And now we transpose 5 from the LHS numerator to the RHS denominator. And thus we have k equals to 20 upon 5 equals to 4. Therefore, the unknown number is 4.
Question 5.
6 times the sum of a number and 15 is minus 42. Find the number.
Let the missing number be k again, because k is giving us success, so why not stick to it? The question is talking about the sum of a number and 15. So k plus 15. But this question is not just talking about that sum, but 6 times that sum. So let's say we want to multiply 6 by the entirety of k plus 15. So we can put it down this way. 6 into, within brackets, k plus 15, close bracket. And the question is saying that this sum is minus 42. Negative number, interesting. So we'll say equals to minus 42. The equation we have formed is 6 into left bracket k plus 15, right bracket, equals to minus 42. So we can transpose 6 from being in multiplication on the LHS to going into division on the RHS. Thus we have k plus 15 equals to minus 42 upon 6. So according to the rules of division with positive and negative numbers, as long as we have one negative sign only, therefore the quotient will be negative. So minus 42 upon 6 will be minus 7. So k plus 15 equals to minus 7 is where we have reached so far. Transposing 15 from the LHS to the RHS, we have k equals to minus 7 minus 15, because positive to negative as it switched sides, and minus 7 minus 15, two like numbers, both negative, so we would add 7 and 15, 22, and stick back the negative sign, so minus 22. Therefore k equals to minus 22. The unknown number is minus 22.
Question 6.
3 consecutive odd numbers have a sum of 45. Find the numbers.
This is a difficult question because we've got 3 numbers to find, 3 consecutive odd numbers. So if we were to say let the first of these 3 numbers be x, the second be y, the third be z, then we could represent that since the sum of these 3 numbers is 45, x plus y plus z equals to 45. But what are you going to do afterwards? Are you going to try x equals to 1, y equals to 3, z equals to 5 as the smallest positive case of consecutive odd numbers, and then try 3, 5, 7, 5, 7, 9 triplets until you finally get bored out of your mind. Trial and error is not an elegant way to approach mathematics. Let's really think about how to simplify this scenario into just one variable. I haven't even talked about or taught you anything about three variables in one equation. How can we express this situation using one variable and one variable alone? Now, if I say that the smallest of these three consecutive odd numbers is k, then can I say that the second of these three would be k plus 2 and the third would be k plus 2 plus 2 or k plus 4? Because if you think about odd numbers 1, 3, 5, 7, 9, etc., the property is that the next odd number is 2 more than the previous one. So consecutive and odd together allow us to use k, k plus 2 and k plus 4 as representations of all three consecutive odd numbers with the help of just one variable k, wherein k represents the smallest of these three consecutive odd numbers. So let's start forming an equation and solving for k. K plus 2 plus k plus 4 equals to 45. Therefore, we've got k plus k plus k, three of them, so we can club them and we have 3k. On the constants, we have plus 2 plus 4, so we can combine them and say plus 6. Therefore, on the LHS, we've got 3k plus 6. On the RHS, we've got 45. Therefore, transposing 6 from the LHS to the RHS, we have 3k equals to 45 minus 6 equals to 39, of course. 3k equals to 39. Transposing 3 from the LHS numerator to the RHS denominator, we have k equals to 39 upon 3 equals to 13. Therefore, k equals to 13. But 13 is just the smallest of these three consecutive odd numbers. We still need to find the second and third, right? But the second number is nothing but k plus 2, that is 13 plus 2, that is 15. And the third of the trio is k plus 4, 13 plus 4, 17. Therefore, the numbers we are looking for are 13, 15, and 17. You can verify this in fact because 13, 15, 17 are all odd. They are consecutive odd numbers, and 13 plus 15 plus 17 on calculation does indeed give us 45. Alright, that's it for this lesson. We'll be doing another set of word problems in the next lesson and then wrap up with the linear equations in one variable chapter. What you need to take away crucially is that the answer is not as important as the logic and the thinking that goes behind finding it. So review the questions and think about how you could have come up with the solutions to the questions that you were unable to this time around yourself the next time you hear a similar question. Comment your doubts below, share this with your friends, subscribe for more. Catch you in the next one.